Good morning. I'm NASA Press Secretary Jackie McGinnis, and joining us today are leaders from both NASA and the National Oceanic and Atmospheric Association, NOAA. We have NASA Administrator Bill Nelson, Kate Calvin, NASA's Chief Scientist and Senior Climate Advisor, Gavin Schmidt, Director of NASA's Goddard Institute for Space Studies, Carlos Del Castillo, Chief of the Ocean Ecology Laboratory at NASA's Goddard Space Flight Center, Sarah Kapnick, Chief Scientist at NOAA, and Russ Vose, the Chief of the Climate Analysis and Synthesis Branch at NOAA's National Centers for Environmental Information, who will be available for the Q&A portion. They'll provide an update on the latest temperature data from July 2023. And first we'll hear from NASA Administrator Bill Nelson. Over to you, sir.
Hey, everybody. It certainly is self-evident that the Earth is heating up. And what we find is that July of this year, the temperatures are the hottest ever on record. If you compare it back to July of 2019, that was the hottest. And now this July has shattered the previous record from 2019 by 0.2 of a degree Celsius. So just look around you and you'll see what's happened. We have record flooding in Vermont. We have record heat in Phoenix and in Miami. We have major parts of the country that have been blanketed by wildfire smoke. And of course, what we're watching in real time, the disaster that has occurred in Hawaii with the wildfires, which were in part fueled by a typhoon or hurricane that was out in the Pacific. Well, we're trying to do something about this. And I'll take you back to when Senator Joe Biden and Sheldon Whitehouse and I were some of those senators who warned what was coming. And now as president, Joe Biden, he's warning again, and he has a climate agenda, and that is very specific. And we can go over the details of that for you, but not only is it addressing the wildfires, the electric grid, the biggest climate change bill that has passed in the history of the Congress, all of that is happening. And I can tell you that NASA is all in. Most people think of us as a space agency or an aeronautical research agency. We are also a climate agency. And why? Because we have all those assets up there that are taking very precise measurements of what is happening. And from all of those measurements, we decided that we were going to, in the spirit of, if you remember on a space flight, you have a mission control center, and all of that information is in one room. Well, we have put together, along with other agencies, the Earth Information Center. First actual physical location is in the east lobby of our NASA building, downtown Washington. But we are making it available real-time information to everyone. And that's through nasa.gov. If you go to our website, you can locate it, you can tap on it, and you've got the information real-time on what these some 20 plus instruments that are up in space that are giving us very precise readings. What we have just put up, if you look in the recent past, we put up an instrument called SWOT. It is giving us the first time the elevation and the characterization of fresh water. First time, elevation of water, lakes, ponds, rivers, streams, reservoirs. We put up tempo. It is giving us air pollution data. We put up emit to measure the mineral dust that is up drifting across the globe. And lo and behold, it gave us the definition and locations of methane emissions on the globe. And more recently, we put up a mission called Tropics that is helping us characterize further definition on hurricanes and typhoons. What we're trying to do is we're trying to bring space down to earth. And I'll give you an example. About a year ago, I went to Kansas. I wanted to visit farmers there. I wanted to talk to them about the data that is available from our instruments in space that would give them specific information, for example, on the moisture content of their soil where they're planting their crops, so they can plan on their irrigation depending on what that moisture content was. And that way, they can save a lot of water on irrigation. Or, for example, the information that we can give to prevent wildfires. We can detect disease in trees. And we can also give an indication from instruments for firefighters real time what's happening to that fire as we look at it from space. And another example, we are experimenting with a paint coating on asphalt in Los Angeles. And what we're finding is that it is allowing a neighborhood to be cooled by that paint surface reflecting the heat instead of it being absorbed by the asphalt. Well, the bottom line of all this is the last 9 years are the warmest on record. And folks, Mother Nature is sending us a message. And that message is we better act now before it's too late to save our climate. In other words, to save our planet. And the bottom line also is there's no political boundaries and there are no geographical boundaries. We are all in this together. Back over to you, Kate.
Thank you, sir. So we know from observations made on and above the Earth's surface that climate is changing. This July was the warmest July on record, and collectively the last 9 years have been the warmest since modern record keeping began. Climate change is having impacts on people and ecosystems all around the world. Along with changes in temperature, we're experiencing other changes in climate, like sea level rise, declines in Arctic sea ice, wildfires, heavy precipitation events, and more. At NASA, we're observing the Earth so we can understand both what's happening today, but also how that's changed over time. So we can observe the impacts of climate change, like sea level rise, wildfire, extreme heat. We can also observe the drivers of climate change, like greenhouse gases, carbon dioxide and methane that are increasing in the atmosphere and trapping heat. By observing this, we can understand both what is happening now and also why it's happening and provide that information to inform decision makers and the public. So all of the data that NASA collects is publicly available, and we're working to make it easier to use so that people can understand what's happening in their communities and help plan for the future. And what you'll hear about today is a little bit more about the recent records and predictions of the future. And so I'll turn it to Dr. Gavin Schmidt to talk about recent data and observations.
Thank you very much, Kate. So we are producing today the GISS temp analysis of global temperature anomalies. These are an analysis based on weather station data, ocean buoys, ship records, and automatic weather stations in Antarctica and elsewhere, put together to give an estimate of the global mean temperatures, and that estimate goes back to the 19th century. The results that we're presenting today for July show that July 2023 was by far the warmest July in the record, more than 0.2 degrees Celsius warmer than the previous record, which was in July 2019, and more warm still than the last time that we gave a kind of mid-year press briefing on the temperatures, which was in July 2016. The temperatures in